Hi guys, we're continuing our study of functions, and now we're going to look at inverse functions. This is a bit long, so we're going to do it in two parts. How are you going to start? Well, we're going to first start to think about what is an inverse function. What is it designed to do? So what I want you to think about this is imagine that we have got a function. Okay, so the function here is this little box. We'll call that f of x. What does the function do? It takes in inputs. So here we got inputs, and it spits out outputs. Okay, so a function takes in inputs and gives out outputs. And typically we describe the inputs using the variable x and the outputs with the variable y. So what does an inverse function do? Well, it just inverts that order. It kind of takes you from the outputs back to your inputs, right? So we call the inverse function here f minus 1 of x. So that's our inverse function. What does it do? It takes the outputs of the original function as inputs and returns as outputs the original inputs to the function. Okay? So an inverse function takes you from your outputs back to your inputs. That's the big idea. So if we were to imagine a function, let's say the input to this function was 2, and the output of the original function was 7, then what we should expect from an inverse function is if I take that output of 7 and make it an input of my inverse function, then it should give me back 2. It should return me back to my original input. So just to clarify that, you start with 2, you input it into your original function, you get an output of 7. You then take that output of 7, you input it into your inverse function, and it returns you back to the value of 2, which was your input. Okay, so that's the idea of an inverse function. But the question is, well, how do we calculate or compute what an inverse function is going to be? So imagine we have got an inverse function like this. F of x is equal to 2x minus 10. So let's rewrite that. Y is equal to 2x minus 10. Remember, what's our input? Our input is our x value. And what's our output? Our output is our y value. So what do we want for the inverse function? Well, we just want to rearrange it so that the input becomes the subject. Right, so that we get x is equal to something in terms of y, right, and something in terms of the output. So we're going to rearrange this. So we get y minus 10, sorry, not y minus 10, y plus 10 is equal to 2x, which means that x is equal to a half y plus 5. You see what we've done there? We've now been able to find out what x is, what our input is, in terms of y, our output. Okay? So then the final step, if we want to write this as an inverse function, right, f inverse of x, then all we do is we take our y values and we just replace them by x. Okay, so a half x plus 5 instead of a half y plus 5. And why is that? Well, because all we're saying is that the outputs of our original function, our y's, become the inputs of our inverse function, the x's, right? So if you go back to the original diagram, what I'm saying is the outputs here, y, become the inputs of the inverse function. They become the x values, right? So that's why we're doing the switch there. Okay. So we've done that with one function. Why don't we just do it with another? That might be helpful. Let's say you wanted to find the inverse of f of x is equal to 3x plus 12, for example. What am I telling you to do? You rewrite that. Y is equal to 3x plus 12. You rearrange it. So y minus 12 is equal to 3x. So x is equal to a third of y minus 4. And all you do is you replace the y values with x, so you get a third x minus 4. That is your inverse function there. Okay, well, let's extend our thought a little bit. Let's go back to what we previously considered about functions, and that is to think about the domain and the range. Now, if you can't remember what domain and range are, here are the definitions from a previous video. The key idea is that domain is the input values, that is the x values, and the range is the output values, that is the y values, right? So domain is the set of all of the inputs, and the range is the set of all of the outputs. Now, let's think about what that means. Let's go to our original function f of x. The domain of f of x is going to be the set of all inputs that can go in, right? So the domain of f of x is the set of inputs here. And the range of f of x is the set of all outputs that you can get. Right? So the domain of f of x is the set of inputs, and the range of f of x is the set of outputs. Remember, what we're saying about the inverse function is that the outputs of f of x become the inputs of the inverse function, right? So these outputs here become the inputs of our inverse function, right? They become the x's of our inverse function. So if you think about it, the domain of the inverse function, so the domain of the inverse function, which is all the set of inputs to the inverse function, has got to be the same as the range of the original function, right? So in other words, what I'm saying is this thing here in blue, I've got to do it in yellow, that thing there has got to be the same as this thing here. Why? Because the outputs of the original function become the inputs of the inverse function. In the same way, right, let's think about the outputs of our inverse function, right? Our y values that come out of the inverse function. So these set of values would be the range of the inverse function, the range of f inverse x. But think about this, right? The set of the output values for the inverse function, right? These y values here, right? They must be the same as the set of input values to the original function, right? Why is that? Because the whole purpose of the inverse function is to return you back to your original inputs. And if that's the case, what it means is that the range of the inverse function, right, the set of all output values for the inverse function must be the same as the domain of the original function, right? Because the outputs of the inverse function should be the same as your inputs to the original function. So what I'm trying to tell you is that the things in yellow should be the same and the things in green should be the same, right? So the range of the original function becomes the domain of your inverse function, and the range of your inverse function is the domain of your original function. That's the key idea. Let's put it into practice because it seems a bit abstract before we actually do a question. So let's do a question together. Okay? We want to find the inverse function of this thing here. F of x is equal to the square root of x minus 1 plus 2. Now, before we find the inverse function of this, what I want to do is I want to actually sketch what this looks like. So I'm going to try to sketch this. So I'm going to rewrite it. Y is equal to the square root of x minus 1 plus 2. And I'm going to rearrange it a little bit. Y minus 2 is equal to the square root of x minus 1. And what I want you to notice is that this graph is basically the same as y is equal to the square root of x, but there are two shifts which are taking place, right? Here what you've got is you've got a shift in the x direction by 1. So this is a shift right by 1. Why? Because you've replaced x with x minus 1. What's this? This is a shift up by 2 because you've replaced y with y minus 2. Okay? So what I want to get you to think of is we're going to extend the idea of shifting and scaling that we learned earlier to this particular graph. So what I'm saying here is that if we know what the graph of y equals the square root of x looks like, so y equals square root of x looks like that, then we should know what f of x looks like, because it's just a shift to the right by 1, and it's a shift up by 2. So there's 1, there's 2. So our graph should look like that, okay? Because we've taken the original function, the blue function, we've shifted it to the right by 1, we've shifted it up by 2. So this thing here is f of x. Okay, that is f of x. Okay, having done that, let's now try to ask the question, what is the domain and what is the range of f of x? All right, let's try to do that. Okay, now the domain, you should remember, is the set of all input values. So what input values can we have? Why, there must be values of x which are greater than 1. Okay, so we can say that the domain of f of x is x is greater than or equal to 1. Okay, that. What about the range? Well, the range is the set of all output values, right? So we expect the output values there to be greater than 2. So we can then say that the range of f of x is that y must be greater than or equal to 2. Okay, so far so good. So by drawing this diagram, we're able to see what is the domain, what are all of the x values, and what is the range, what are all of the y values. Now remember what I just said a moment ago. I said that the domain, I said that the range of f of x becomes the domain of the inverse function. Right? So the range of the original function becomes the domain of the inverse function. So what will be the domain of the inverse function? Well, it's going to be the same as the range of the original function. So if the range of the original function was y is greater than or equal to 2, the domain of the inverse function is x has got to be greater than or equal to 2. Okay? That's the domain of the inverse function. And if the range of the inverse function is going to give me the same set of values as the domain of the original function, well, what's that going to be? Well, if the domain of the original function is x is greater than 1, then the range of the inverse function will be that y must be greater than or equal to 1. So what I'm saying is, these things here should be the same, and these things here should be the same. Right? So the domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the inverse function. In other words, range and domain, they swap. Okay? So to clarify, for my inverse function, what I'm going to be expecting is this. Right? I'm going to expect that the domain of my inverse function is going to be greater than 2. And I'm going to expect that the range of my inverse function is going to be y is greater than 1. Okay, that's what I'm going to be expecting. So let's now try to calculate what our inverse function is going to look like. Okay, so we go back, we do what we did before. I've got that y is equal to the square root of x minus 1 plus 2. I'm going to rearrange this. I'm going to get y minus 2 is equal to the square root of x minus 1. I'm going to square both sides, so y minus 2 squared is equal to x minus 1. And therefore, x is equal to y minus 2 squared plus 1. And of course, the last step is to call it the inverse function. What I've got to do is I've got to replace my y with x. So this is x minus 2 squared plus 1. Okay. Now then, the question is, well, what does that look like And hopefully what you should know by now is that that's going to look like a quadratic, isn't it? Right? And what kind of quadratic is that going to look like? It's a quadratic which has been shifted to the right by 2, and it's been shifted up by 1, right? So quadratic that's been shifted to the right by 2 and up by 1, so that's going to be the key point. And so it's going to look like this. Okay, that's going to be our inverse function. But hang on, if we just go back to the previous slide, we just said that the domain of this inverse function is x is greater than 2, and the range of this inverse function is y is greater than 1. So let's just put that in, shall we? We expect that the domain of this, so domain, should be that x is greater than or equal to 2, and that the range should be that y is greater than or equal to 1. So if we say that the domain is x is greater than or equal to 2, then what we're talking about is we're talking about all of these values only. In other words, these values here on the left-hand side, they're excluded, right? They're not part of the inverse function. So what are we going to do? We want to draw the inverse function. Do that again, hang on. We've got to make sure that we get rid of the left-hand side and we just draw the right-hand side. Okay? Why? Because the range of our original function becomes the domain of our inverse function, and the domain of our original function is the range of our inverse. Okay, domain and range, they switch. So remember what I said, if we go back to the previous slide, we said that for our function, for our inverse function, we expected that the domain would be greater than 2, right? So everything from here onwards, and the range would be greater than 1, right? Everything from there onwards. And that is what we've got, right? We've got a function that looks like that. Okay? All right, guys. Now, that is fairly complicated. I do accept that. But the key thing for you really is you want to try to understand what is the inverse function actually doing? What are we trying to accomplish? And the key idea is that it's taking us from the outputs back to the inputs. That's the big idea. And therefore, that should help you to understand what's going on with domain and range, right? Because if domain is the set of inputs and range is the set of outputs, then what we should expect for an inverse function is that these values become swapped. And if you can understand that idea, then these questions about finding the inverse function will become a bit more intelligible. We're going to do another video that will explain it with a slightly more complicated example, and hopefully with that, things may make a bit more sense. Okay, thank you very much, guys. I'll see you in the next video.